Hello everyone, here's my first video for Geometry, Westwood Academy, Chapter 1, Basics of Geometry, Section 1.1, Points, Lines, and Planes. You're going to want to read all of these notes that are in here, and then you're also going to want to watch this YouTube video or this. They're the same link. You're going to go to the Google page that we have for our classroom, our global classroom. And you'll find links here, and you're going to write a 350 word reflection on the video. Okay. Then you're going to have to go through and fill in definitions, define what undefined terms means. You're going to do your best effort to try and give a description of point, line, and plane. You can't define point, line, and plane. They are undefined terms. They come from Euclid. And you're going to do your best effort to try and give a description of them. Flip to the back side. You're going to want to read our book's descriptions of point, line, and plane. And then you're going to go through and start defining defined terms, collinear points, coplanar points. You're going to take a look at these examples of what they are. Look at the pictures so that you understand what it is we're talking about when we talk about coplanar points or collinear points. And now we're into example 1. So example 1 comes with this diagram, and it asks us give two other names for line DE and plane C. So line DE is here. And there are many other answers. We can give way more than two, but two possible ones are line DA with proper notation, line AE with proper notation, line R. As you can see, there's this little R here, indicating that this is line R. Of course, you can also switch the A and the D. You can switch the A and the E. And those are two different, that's three examples of names for line DE. We're going to give you some more names for plane C. Another name for plane C would be plane DFE. That's a name for plane C. Another name for plane C would be plane DFA. And there's a second name for plane C. I could, if I wanted to, name plane C plane DFAE. And the only thing that we need to do when naming the planes is make sure that these points are non-collinear. We want them to be non-collinear. They do not line up. All right, part B. Name 3 points that are collinear. So we have two choices here. Sorry, we have one choice here. We have points D, A, and E. Those 3 points are lining up on line R. They are collinear. And there's our answer for part B. Name 4 points that are coplanar, 4 points that are in the same plane. And that would be points D, F, A, and E. Are all points that are in the same plane. They're all in plane C. I could also, if I wanted to, name points D, A, E, and B. And this one's not as obvious of an answer, but it's a plane that's not drawn in this picture. D, A, E, and B are going to all be contained in the same plane that contains lines line S and line R. So there's another plane is a three-dimensional picture that's going through plane C. It intersects plane C at line R, and it also contains line S. Anytime you have collinear points and a point not on that line, there is one plane that's going to contain those 4 points. So there's example 1. You have some more definitions that you have to some more words that you have to define. And then there's examples of how our book defines those words down below. And then we're on to example 2. Give another name for segment TR. Another name for segment TR is segment RT. And again, notice the notation is for a segment. Name all rays with endpoint P. So we have ray PS, ray PT, ray PQ, and ray PR. These are all rays with endpoint P. Now notice the notation, the ray symbol always goes to the right, and it doesn't matter if the ray goes to the right, which this one does for PS and PR, but for PQ it goes to the upper left, PT it goes to the bottom left, but the notation always goes to the right. Notice point P, which is called an ending point, but you could think of it more like a starting point if you want to. P is always the first letter in the ray. Ray RP is a completely different ray. Which of these rays are opposite rays? So there are 2 pairs of opposite rays. Ray PS and ray PQ are opposite rays, and ray PT and ray PR are opposite rays. So there's our answers to example 2. We have another word here that you have to define, intersection, and then I have a whole bunch of visual diagrams of different types of intersections that you're going to want to read and take a look at and get to know. And we'll move on to example 3. Sketch the intersection of lines A and B that lie in plane W. So we want to sketch the intersection of lines A and B that lie in plane W. I would recommend drawing plane W first. And again, I'm just doing a quick sketch here. This is nothing fancy. I'm not pulling out a ruler or anything. We're going to draw line A in here. And we're going to draw line B. And these are intersecting right there in plane W. Sketch line D that intersects plane D. Sketch line D that intersects plane D in only one point. And we're going to label that point A. So to do that, we're going to have to draw something three-dimensional. And again, I'm going to start off by drawing plane D, capital D. And then I'm going to have a line that's going through plane D. So imagine that this plane D is like this paper right now, and the pencil is like line D. The pencil is touching that plane at just one point as it goes through the plane D three-dimensionally. And we're going to draw that. So we have a line, hits the plane. It's hidden by the plane because it's 3D. And then it comes out the underneath. Call this line D, and we're calling this intersection point A. That's one way to draw this picture. In fact, I'm going to go back in a second. I'm going to do all of these in a completely different way. So let's move on to part C. I'm going to show you a second way to do A, B, C, and D. So part C, sketch plane X that contains line PQ and point B not on line PQ. So here's plane X. It's got to contain line PQ. There's P. There's Q. And I need another point B not on line PQ, but is contained in plane X. Okay. Now let's attempt D here. Sketch point P not in plane N, and 3 lines through point P intersecting plane N, and the points intersecting plane N in points A, B, and C. So I'm going to draw our plane N here. I'm going to sketch a point P not in plane N. And now I have 3 lines that go through P. They hit plane N. This one hits at point A. This one hits at point B. And this one hits at point C. And there's an example of a sketch for part D. Now, I said I was going to go back and redo example 3 in a very different way that might be easier for you to do. So I'm going to slide the paper over a little bit. Sketch an intersection of lines A and B that lie in plane W. So oftentimes it's easier for people to draw a cube. So if I draw a cube, and if I draw this is line A, and this, let's do this one, is line B, then this top part of the cube is plane W. And this is a way of sketching 2 lines intersecting in plane W. I can do a similar thing for part B here. Again, draw a cube. And this time, let's do plane D as the top again. But line D this time, let's do this one here. Is over here, little d. And it intersects the plane only at that one point right there. Okay. Sketch plane X that contains line PQ and point B. Again, drawing our cube. Here's plane X. Here's the point B. And here's line P2 contained in plane X. Let's see, part D. I think we can do this one. Let's try that again. Here's our cube. Let's make the top plane So to do part D here with the cube, I'm going to call this point down here point P. Plane N is up here. I'm going to take a line from through P up through here. We'll call this point A, right there. We'll go straight up and down through P. We'll call this point B, and then we'll go across here, and we'll call this point here point C. Okay, so there's example 3, two different ways. Example 4, sketch two planes R and S that intersect at line AB. So again, there's two ways to do this problem. I'm going to start off by drawing a vertical plane. Notice I'm drawing the vertical plane only partly done. I'm going to draw a horizontal plane that's intersecting the vertical plane like this. And I'm going to continue the vertical plane until, let's see if I get this part. And now I've got my two planes, R and S. They're intersecting at line A, B. But right now I only have AB drawn as a segment, so I'm going to continue it so that it looks like a line. Okay, that's one way to do example 4. Another way, again, is with cube. And this is a lot easier. Now you can use any two sides, but I'm going to choose this one here to be R, and this one down here to be S. And these two planes are intersecting right here at line A, B. So there's example 4, done two different ways. Move on to example 5. We're going to name two different planes that contain line QP. So here's line QP. One of the planes is plane QRSP. Notice when I name the plane, I start going around in order. It doesn't matter if you go clockwise or counterclockwise. What I didn't want to do was go QSPR. You don't want to start going across. Okay. Another plane that contains line QP is plane MNQP, the front of the cube here. And there's two different planes that contain line QP. Example 6. Name a line and a plane whose intersection is that line. Okay, so we're going to name a line and a plane whose intersection is that line. Now, I've got many different choices. I'm going to choose the plane down the bottom here. So plane WTSR and line ST. WTSR is down the bottom, line ST is here. That line intersects that plane at the whole line. Okay, wherever that line is, it's in that plane. Okay, and I could have done plane VTS and line VS or line VT. You can name any line that's in the plane that you have named. Okay. Let's do some always, sometimes, never questions. These may seem simple at first, that you only have 3 choices, but you're going to find out this year that always, sometimes, never questions can be tricky, and you do want to pay attention. Intersecting lines are always, sometimes, or never coplanar. The answer here is always. Two lines intersect, they are always coplanar. We'll leave this proof to you later on. Two planes always, sometimes, or never intersect in exactly one point. Two planes always, sometimes, or never intersect in exactly one point. And the answer here is never. If we have two planes, this bottom plane and this front plane, they intersect at line RS. That's intersecting at more than one point. That's an infinite number of points. It's a line. Here we have, up here in this cube, we have the bottom plane and the top plane, and they never intersect. That's not one point. That's 0 points that they intersect at. So they intersect either at a line or they don't intersect at all. So it's never. 3 points are always, sometimes, or never coplanar. And this answer is always. It is impossible to draw 3 points that aren't in the same plane. Now, it is possible that those 3 points are contained in more than one plane, but they're still coplanar. A plane containing 2 points of a line always, sometimes, or never contains the entire line. So what do you think? A plane containing 2 points of a line always, sometimes, or never contains the entire line. Is it possible for 2 points of the line to be in a plane and then the rest of the line to not be on that plane? And the answer is always. 2 points, a plane containing 2 points of a line always contains the entire line. Four points are always, sometimes, or never coplanar. This one we call the 4 points end of a chair. So if you're sitting in a chair that's got 4 legs, if you've ever sat in a chair that rocks a little bit because one of the legs is a little bit shorter from the other legs, that 4th leg of the chair is not in the plane of the floor. 4 points are sometimes coplanar. 2 points always, sometimes, or never meet in more than one point. 2 points always, sometimes, or never meet in more than one point. Is it possible for 2 points to meet in more than one point? Never. 2 lines always, sometimes, or never meet at one point. The answer here is sometimes. Now you might think that the answer is always. Well, what if they never meet? If we have parallel lines, or you're going to learn what skew lines are in the future, they never meet, so their intersection is 0 points. 2 line segments always, sometimes, or never meet in more than one point. This is a very tricky one, and the answer here is sometimes. Most students get this one wrong. It's a very tricky one. Most people, when they think of this, they think, here's 2 segments. They're intersecting at this one point. They can't intersect at more than one point. And the truth is they can, because these are segments, not lines. Let me draw this example here. A, B, C, and D. And let's take a look at segment AC and segment BD. Where does segment AC and segment BD intersect? They intersect right here at segment BC. The intersection of segment AC and segment BD is segment BC. That's more than one point. It's an infinite number of points. It's a whole segment that they're intersecting at. So the answer for part H is sometimes. Now let's take a look at example 8. How many planes contain the same 3 collinear points? The answer is an infinite number. And that can be a little bit tricky. So how many planes contain the same 3 points? So I'm going to come over here. Imagine this is my pencil, and this pencil has 3 points on it. Okay, so now you're looking in the picture-in-picture. Don't look down here. Look up here. So 3 points in this plane. And if I take this piece of paper is containing the plane, is containing the pencil, right? Well, I can rotate this plane to here. That's a different plane containing the pencil. And here, that's a different plane containing the pencil. And a different plane containing the pencil. And I'm not moving the pencil. I'm showing you different planes containing that same pencil. There are an infinite number of planes that contain that pencil. And the pencil contains collinear points. Example 9. Classify each statement as true or false. Line PF ends at point P. True or false? False. Lines don't end. Point S is on an infinite number of lines. True. There's an infinite number of lines that can go through a single point S. A plane has no thickness. That's also true. Part of the description of a plane has no thickness. Collinear points are coplanar. That's true. They're contained in many planes, but they are coplanar. Planes have edges. This is very similar. It's analogous to example 9a. Planes have edges is false. Just like lines don't have endpoints, planes do not have edges. 2 planes intersect in a line segment. This is also false. 2 planes intersect in a line, not a line segment. 2 intersecting lines meet in exactly 1 point. And the key words here are 2 intersecting lines. If it just said 2 lines, this answer would be false because they might not intersect. But I'm being told that these are intersecting lines. They must meet in exactly 1 point. This is true. Points have no size. That is true. It's part of their description. Euclid gave a pretty interesting description of what a point was. You might want to look it up sometime. It's kind of different. But points have no size. They make up things that do have size, but them themselves, they have no size. Line XY can be denoted XY or YX. This is true. The order in which you put these points for the naming of a line is irrelevant. It's only relevant when we're naming an array. Here's your bookwork that you have to work on in the next class. And I hope you got something out of this video and this answered any of the questions that you may have had when trying to fill in these skeleton notes. See you next time.